Problem number 1. A relation is sometimes a function. Remember that in order for it to be a function, it cannot have repeating x values. A set of or list of ordered pairs can have repeating x values and still be a relation, though. So a relation is sometimes a function, but a function is always a relation. A function is always a set of x, y values that, when graphed, passes our vertical line test. And so they would also classify as a relation. Problem number 3. Identify the following function as whether or not it's a function or not a function. This problem is actually a function because we see that our x value of 1 is going to both 3 and 3. And if I were to graph that on a graph, we would end up with one ordered pair sitting at 1, 3, and a second ordered pair sitting at 3, 5. And so there's really only two ordered pairs on this particular problem. And thus we end up with a function. Would it be linear? If you have 2 points, any line connecting 2 points is always going to be linear. Number 4, function or not function. Well, we end up with 1 in its own x value, 2 in its own x value, and 3 in its own x value. And it's kind of hard to tell whether or not it's linear when my x values are not in numerical order. So I'm going to change them into numerical order. We end up with 1, 2, and 3. And by changing them into numerical order, we need to make sure that the paired y value is still directly across. So I'm going to go ahead and write it just so that we see that they are. 2 is 4, 3 is 6. Now, in order for them to be linear, we need to have a constant rate of change in both our x and our y values. So let's look at our rate of change. Since we line these up numerically, we have a rate of change of 1 and 1. Over on our y values, we have a rate of change of 2 and 2. And so our slope for this particular equation of a line would be a slope of 2, and it would be linear. Number 5. We have a 1 going to a 3, we have a 1 going to a 3, and we have a 4 going to a 5. So again, we have linear function. The reason we have a linear function is since 1, 3 is a repeated ordered pair, we're going to have an ordered pair that sits at the same point. So really, when we look at a graph, we're only going to see 2 ordered pairs, and anytime you connect 2 ordered pairs, you end up with a straight line. Number 6, function or not function. That's obviously a function because it's a straight line that would pass the vertical line test. And since it's a straight line, it would be linear. Number 7, again, we have a function. There's not a constant rate of change, so we're going to call this a function that is not linear. Number 8, we do not have any repeating x values, so our vertical line, no matter where we draw it on this image, would pass the vertical line test, so we have a function. And again, we obviously have curves on this one, so not linear. Number 9, state if the following are functions or relations. If it is a function, state the domain and range. So we're looking for repeated x values. -1, -2, 0, -2. Now that I have repeating x values, I need to determine, are those repeating x values going to the same y, or are they going to different y's? Well, here we see they're both going to different y's. Just as we talked about in class, that any given student can't go to 2 parties at the exact same time, any given x value cannot have 2 different y's at the same time. And so that would make it not a function. So we'll just call that a relation. Number 10. We have a 3, an 8, a 0, and a 2. There are no repeating x values. So this would be a relation and a function. Since it's a function, we're going to state its domain. Domain is all its possible x values. 3. Oh, we have a lower than 3. 0, 2, 3, and 8. The range, all of our possible y values. We have 6, 6, 6, and 6. So that was real quick and easy. Number 11. We have a 1, a 9, a -1, and a -9. No repeating x values. So we're going to have a relation and a function. We want to list our domain and range. The domain is all of our x values, starting with our lowest, which would be -9, -1, 1, 9. And the range, all of our y values. So our lowest value is going to be -4. Two, which repeats itself, so we don't need to list it more than once. And 9. Problem number 12. We have -1, 8, -2, and 6. There are no repeating x values, so again we have a relation and a function. So I need to find my domain and my range. Domain, starting with our lowest x value, -2, -1, (6 and 8). And my range, starting with my lowest y value, we have -2 twice, but it's repeated. That's okay. -1 and 3. Problem number 7. We have 0, -2, 0, 2. Well, my 0x value has been repeated more than once, so I need to evaluate the y values that go with them. -2 and 0. 0 of an x value cannot be at more than one y value at the same time and still qualify as a function. So we have simply a relation. Number 14, -9, 7, -1, 2. No repeating x values, so we have a relation and a function. So we need to list our domain and range. The domain is going to be my lowest x value, -9, -1, 2 and 7. My range will be my list of possible y values, starting with my lowest. Looks like we have -5, 1, 2, and 9.